do one thing, okay? How many of you know the answer? You can raise your hands. At least you can raise your hands, and one after the other, you can unmute and you can tell it. Okay? Will this work? Please say yes or no. Okay. Okay, at least a reaction. Yeah, that's fine. Okay. So yesterday we have discussed on that one, and we also discussed about the Spark job execution, right? So, what in this Spark execution, the two main important things are in RDD. RDD is having two main things. What are they? Hello, am I audible? Yes, yes, you can unmute yourself and tell who has raised the hand. Okay, let me recap it once again and I will ask you questions once again. Okay, so in this Spark execution, we have two things. One is transformations and one other one is actions. What do the transformations do and what do the actions do? We discussed yesterday. So what when you write any program, then what it will happen? Whatever it is. So the job will get initiated only when the action has been triggered. Unless the action has not been triggered, for all the transformations, the RDDs will get created. Okay, so RDDs will keep on getting created, and there will be a DAG yesterday, which I told you. The important thing, DAG means directed acyclic graph. So this is a graph. So what it will do for every job it has taken, it will create a graphs like for every job. Each job is having this cluster manager. So what it will do, it will be dividing the the job into different it will be assigning the work to different worker nodes, and each node is having again what are these worker nodes called? Yesterday we discussed these are all our stages: stage 1, stage 2 and stage 3. uh, is my screen visible? Can anyone please?
Not visible, not visible. Maybe you're not sharing.
No, ma'am.
Are you sharing it?
Yes, ma'am.
But okay, the sharing has been disabled for me, sir, today. Actually, in the initial session, I have access to share the screen, but now,
Oh, is it?
yes,
You're
yes,
sharing?
sir.
Okay,
Huh?
just a second.
It is saying only meeting organizers and presenters can share.
Just a second. I did something. Mute participant, disable. Okay, so just a second.
Sure, sir.
Can you check now?
Yes, sir. It has been enabled now, and I'm sharing the screen. Is my screen visible, sir? No?
Yeah. Yeah, visible.
Okay. Yeah. So I will start this once again for your better understanding. Okay. The Spark job execution. So whenever you write any program, this will create a job. So the job will get created upon triggering the actions. These actions, once the actions are triggered, then only you will be executing the tasks divided. Okay, until the actions are not initialized, only the transformations, what they will do, they will keep on creating RDDs one on one, and they will also create this DAG. What this DAG mean is directed acyclic graph. So for each and every job which we execute, it will show the graph that is how many stages we need to divide this job, and what are the tasks for each and every stage it will show. Okay, so this is the directed acyclic graph. So this is the major one. When the action is triggered, what it will do, it will analyze this directed acyclic graph, like okay, what stages are there and what needs to be executed after what. This will analyze that one, and it will get executed in such an order. Okay, so as we discussed yesterday, here we have cluster manager, which will allocate the resources and instruct the workers to what to do. Okay, so this is the cluster manager, and here you could see these all are the worker nodes. So again, for all the worker nodes, means we can say this as a worker node or this as a stage. For each and every stage, we will be having the multiple tasks again within the stages. Okay, understand this, because today in whatever the functions we are going to execute, all these require this knowledge. That's why I'm reiterating this one. Okay, so we'll be having multiple stages. In each stage we'll be having the tasks. Okay, so this is how it is being executed. When the uh, stage has been completed, this all stages have been completed, all this will be accumulated into one, and then the result has been again sent to the driver program. So this is how it executes. Okay, so here we will be learning many more things, like there are different types of stages. What are those stages? And here you see this is a executor. So we will be having different types of executors also. The executors are based on how much memory it takes. Like sometimes it is a very basic query, so it requires very less memory, right? So it depends on few executors take less memory. That is categorized into coarse grained. So each and every executor, like if it is a simple one, if it is using the less memory, that is one type of executor. If it is using more memory, then for a larger data set, if we are processing that one, it will take more memory. Then again, that is categorized into another executor. So the standalone one, which is a general purpose one, it is again a different type of executor. So for every thing which was written here is having its own definition. Okay, the core, task, executor, worker node, DAG, directed acyclic graph, cluster manager, driver program. So each and everything what was written here has its own definition. Okay, so I hope this tomorrow when I ask any question in this one, definitely you will be able to tell me tomorrow. I hope. So I'll be going forward today. Okay. So yesterday we discussed a few actions. And today we will be going to discuss about the actions and also the transformations as well. So in this RDD operations, transformations and actions. So yesterday, what we have discussed about these actions, what functions we have used. If you remember, we have used the collect one to collect the data, and we have used the count function. We have used, got to know what this for each function, I mean, what this for each do, we have taken that one. So today I will be take off also we have learned. So today I'll be telling you the important one. See this reduce and fold. So these are the few important action operations, okay, which we need to learn. So I'll be telling you this one, and also there is one more function, take sample of. So I'll be discussing starting the session with those actions, and then we'll be moving forward today. Okay. Can anyone tell me what will be the answer for? Let me. Today we have question and answer one. Sir, I can post the question and answer here, right? I can ask question, right? It will be working, right?
You can directly ask question.
Yeah, okay, sure, sir. So, can anyone tell me what will be the answer for if I say se dot parallelize of, and I'm taking an array of 50, 29, and 30, 48. So these are the ones. And if I say distant of count of, how many we will be getting? It is a very basic one, similar to your SQL queries. Please
No,
answer
no, I
this.
see. No, no. If this much question, then better you write it on a notepad and share your screen. Okay. You
Okay.
you
Okay,
write
sir.
the query on
Uh,
a notepad and share it on the screen. They will guess the output. Okay. It's
yeah, okay,
remember
sir.
very difficult to remember. Yeah.
Okay,
Just
okay.
open a notepad
I
and
will
write your, yeah.
I will open a Databricks notebook, and here only I will.
Okay. Yeah, that is also fine.
See, this time I'm not getting the answers. Everyone, please open your notebooks. You can execute and you can tell me the answer also. So here, if you see, it is not coming. Yesterday, when we are writing something, it is popping up something with whatever functions it is having. Today, it is not. Why? Because the cluster is not detached. So let me quickly attach the cluster. So there is one more thing. We are using this Databricks community version, right? So it will get terminated after some time when you don't use it. So every day you need to create one cluster. So I will delete few so that I can create a new one. I cannot start this one. Oh, this is starting. Wait. I cannot start this one because it is currently disabled for me. I don't have that access. But in our general Azure Databricks, it will get terminated. But every time you want, you can start it right from the notebook itself. No need to come to compute every time. Okay. So today also you can create a compute. Everyone open your notebooks and create a compute along with me. I hope everyone has opened your notebooks. In the Databricks notebook, sorry, in the Databricks workspace, come to the compute section. And in the right side, you will be getting an option to create a compute. Click on that one. Give the compute name whatever you want. It can be of anything. And keep the Databricks runtime unchanged. Keep it as is. And then click on Create Compute. It will take some time. Okay. So from tomorrow onwards, what we can do is we shall start. Maybe you might be doing some assignments also from today onwards. So be sure that whenever you come to the class, before coming to the class, you create a cluster, because every day it will get terminated. Okay. Delete the older one and you can create the new one. I hope this procedure is clear for everyone and you all will be able to start the cluster, creating the cluster. If anyone is having, let me know. Any doubts, let me know. Okay. I'm going to the workspace. I have created the session too. So it is in starting stage. Okay. Let me write a question in the meantime for you. Okay. So this for this question, the question is, I want the distant count of A. The question is, again, I'm repeating, the question is the distinct count of this A. It is very simple. It is similar to your SQL.
5. It is 5. 5.
Correct. Yes. See. Here is the answer 5. Yes, you are right. So yesterday in the session, we have discussed about the most important thing, that is initializing the Spark session. Okay, I will be repeating the same thing today also, tomorrow also, every day, so that even in your sleep, you will be able to answer that one, like how to initialize the Spark session. Okay, I will be repeating it louder. So everyone open your notebooks only. I will be saying it louder. You can follow me and you can type it. Okay. Say it louder from your end. No need to unmute yourself. Okay. From PySpark.sql Spark session, import Spark session. And now again, we are creating a variable Spark is equal to Spark session dot builder dot app name of, you can give your own example one I'm giving again, dot get or create of. And now I have created a Spark. See, in the first statement, I'm importing the Spark session. And in the second statement, what I'm doing, I'm initializing it and configuring it, taking the builder here, a builder instance here, and I'm giving the name, app name. App name is as example one. If we have this already, it will retrieve it. If not, it will create it. So that I'll be using this get or create function. And now I'm taking one more variable, and here I'm taking the spark context. I hope everyone are able to follow up with me. See, even if you give it in a small or bigger letters, it is not going to work. It is a camel case one. So be sure that whatever it is, if it is taken in a uppercase, take it in uppercase only. If it is a smaller case, take it in a smaller case only. So Spark session, when we write it as a S is capital and here also S is capital in Spark and session also. But when it comes to the Spark context, S is small and C is capital. Okay, so every day you used to this one, you read this so that you will be able to memorize this even in your sleep. Okay, so this is how we initiate the Spark session. Okay. Now we are going to discuss about the actions which we discussed now. So one action which I'm going to start is, so let me take create a sample one number. Okay. Say dot analyze of. I'm taking an array of numbers again. Okay, now we are going to use the take sample of function with this one. Here you will, here for every command 1, 2, and 3, you will be getting this option to edit this heading. So I'm taking this as take sample. You can give your heading like this one. Okay, so now I'm going to take num dot take sample of. See, if you hover the thing on this one, it will give you, it should be giving some Boolean value here. Give me a moment. Something has started in between. First, we need to give the Boolean value here, and then we need to take what is the size of the sample you want to take. Let me take 4, okay? And let me execute this one and see what is the answer. So, see, here I have taken the Boolean value. See, I have hovered on this one. Let's take a look on this one. So definition is, for take sample is with replacement, which is a Boolean value. That's why we have taken either true or false. So now I'm taking the true one. Okay, and then again we need to take the number, which I have taken as 4. So you can take whatever the samples as you want, you can take. And the other parameter here is a seed. So seed is just a optional one. You want to include it or you don't want to include it, let it be. Okay, for now I'm excluding it. Okay, so see here, 45 has been given only once here, correct? But see how many times it has taken this sample. In the sample which we have taken, 45 has been repeated multiple times, because here we have taken the Boolean value as true. What it actually signifies is we can within the sample, whatever the data is there, it can be duplicated and it can be taken into the RDD. So this is this. Okay, let me execute. See, I'm not changing anything. I'm not changing any of the syntax. Let me execute this once again. Let me see the result of this one. This time, see, it is a 54-54 and 45-45. This means that every time you execute this function, it will retrieve a different results. Okay, let me try with false one and see the results. See, this time it is not duplicated. We are getting a different values. Let me execute this once again and see the answer. This time again it is a different one, 67, 45, 89, and 34. But the common thing, even if you keep it true or if you keep it false, is that it is taking different numbers every time. Means the sample can be repeatedly taken, or we are taking the different numbers from that. But every time you execute it, we are getting a different one. So true means it is accepting the duplicate values. False means it is not accepting the duplicate values. Okay, so now I'm adding the other parameter, which is seed. Seed equal to, you can give any, this is just an optional parameter. Yes, you can unmute yourself. Yes.
Ma'am, even if we take false, we are getting duplicate values. So my array is 23, 76, 89, 46, 12, and 24. The output is 23, 76, 76, and 12. So we are getting duplicates even if I use the parameter false.
Could you please ping me your screenshot? Ideally, the false is, it will not accept the false values actually. You can ping me the
Can I share it in the
screenshot.
group, ma'am?
Yes, you can share it in the group. Should we import the Spark session every time we for execution? No, it is not required. I don't know whose name it is, but what is the thing is, every time I'm saying this because it will be easy for you when someone asks the same question. Okay, that's why we are doing this every day. But ideally, it is not required. Okay. See, let me execute here. Let me execute it one more time and let me see the answer. See, yeah, I too got the same one here. Yes, you are right. What is your name? Who has raised your hand and told me?
Divya Teja.
Divya Teja, yeah, thank you. Yeah, actually, it is giving the duplicate values again in false also. Let us include the seed value now. See, it could be of any value you can give. I'm giving the 5. You can give any random number. So every time, see, from now onwards, every time I execute this one, the answer will never change. Okay, so what it signifies is that when you use seed, it will fix the sample, and there is no particular order you could see, be it ascending or descending, it is not there. But there is one thing, why it is not able to remove the duplicates. That one we need to check on that one. So we shall check on that one. I will get back to you on that one by tomorrow. Okay. So for now, you can take this and we shall continue to the next one. Going to the next one, today we will be discussing again on the reduce and fold one. So for the reduce and fold one, before going to reduce and fold, these two are the two important things. So before going to the reduce and fold, I need to show you one transformation function, that is gloom. Okay. So what do we mean by gloom actually? So in RDD operations, transformations and actions, what it will do actually means we cannot specify the particular RDD. Means if you use the take off function, what it will do, it will take the number of starting from the starting, what is the data we have, it will take till that number, but you couldn't specify the particular RDD, right? What this gloom will do means it will categorize the RDD into tuples. It will convert it into tuple, and it will be easy for us to pick the particular RDD using the gloom function. Okay, so again, I'm using the same one, this time number one, SE dot. Okay, so here I have 4 numbers, and in this one we have another parameter called num slices, right? So now I'm using that particular parameter num slice. So what it will do, it will slice the data into one partition. I mean, the whole one will be shown as well. Okay, well, now we shall see the results. See, even if I show you that the collect of this one, it is showing me the complete array like this one. Now I will show you one more thing. Num1 dot gloom. See here, we are getting two kind of arrays, like one inside the other one. If I change this to 2, let's see what will be the answer. 56, 89, and the other one is 90 and 67. So based on the number what you are giving here, it will be dividing that into random things. If I give 3 here, it will again divide into 3 partitions. Okay, so this is how the gloom works. Now that I can pick any one here, right? So how I can take, thinking from the array perspective, I'm picking the first one. What will be the answer? Let's see. 89. So this is what it has given. If I give 0, I'll be getting the first one. So we using the gloom function, we will be able to pick the particular partition. So this is how it works. Okay. Now we are going to the next one. You can take a note of this one. See, if I have given the partitions like this, it has given me like this. But if I don't give the slices, like how many I want, if I don't give it, what will be the answer? Everyone, you can execute along with me and you can see. I'm not giving anything now. I'm getting more than what I have. I have given only 4 in an array, but how many I got? 1, 2, 3, 4, 5, 6, 7, and 8. So I got 8 partitions of an RDD. So what it is actually reflecting means, see, this is all the one which everyone knows. Means if something is not given, it is taking the default value. So the default value which we have specified for during the configuration of this Spark context is it is 8. How you can check whether it is 8 or some other number or some other? How we will get to know? Let's see here. You can check. We have a default value. Here we are getting default partitions. So the default parallelism and means the partitions which we default is 8 for my system. And I hope this is the same for each and everyone because we are all are going in the same page. So everyone execute this one and you will be getting the answer as 8. It depends on the course, how many we are utilizing. It depends on that one. So basically, this will be the same for all of us. Okay. I hope everyone are following with me. Please say yes or no. Okay, I'm taking this as yes. So now we are going to, we understood what gloom is and how we can utilize this. We have seen now. So let me keep this as one partition for now. Let me go on with the next one. Okay. Now I'm discussing about the reduce and fold. Okay.
Ma'am,
Yes.
what happens if the list size is greater than 8, ma'am? How will it
Sorry.
partition? What if the list size is greater than 8, ma'am?
If the list size is greater than, it will do it. What it will do means, see, firstly, you need to give those many numbers. Okay. Let me give it.
Then each partition will process more than one.
Yes, everything will be. So 9, it is adding up.
Make partitions.
Sorry. See, if you are giving the lesser number than how many elements are there, it is trying to accumulate in one or the other array. But if you are giving it in an exact one, it is taking as is. If you are not giving anything, then it will take into 8 partitions. I have the see This is the very small data set. So we are getting the things as is. But if it is a bigger data set, what it will do means, see, for every job, we will be assigning we have created a compute, right? So for each compute, we will be having a memory size. Based on that one, it will adjust the size to all the partitions. This is how it usually works. Since it is a smaller one, you couldn't see that one, like how it adjusts the larger data set. I hope you understand this one. Please say yes or no. Okay. So now we are going to the reduce and fold. So reduce and fold, both will yield the same results, but there is a difference between those two. Let's see what is that one. Okay, let me use the same num1 here also. And see, I'll give you the other one range. I'll be creating the RDD like this also, range of 1,5. Let me take. So this is a one type of initializing the RDD, giving the specific range. So I'm taking the simple numbers so that in this function, we'll be calculating few things. That's why I have taken 1 to 5. You can take any range, okay? That is up to you. And now we are going to take num2 dot reduce of. Has anyone listened about the lambda functions? I hope you all have heard about the lambda functions in your Python. So anyone can answer this question. What is a lambda function? Before going to this one, please answer that. And then we'll be going forward.
Function having no name is called.
Sorry, please repeat it again.
A function with no name is called lambda function.
Correct. A function with no name is a lambda function. So in Python, we have lambda function, and here also we will be utilizing the lambda function for our operations. Okay, so since there is no name to that one, that is a anonymous function. Okay, now I'm using the lambda function will be used in high level. Yes, can you have any doubt? Hello, am I audible? Please go on
Yes,
mute if you
madam.
are not having any questions.
Yeah, you're audible.
Thank you, sir. So, see, now we are utilizing the lambda functions in our PySpark. So, how we are utilizing? So, in high level, be it in Python or in PySpark, we will be utilizing the lambda functions in reduce, map, and all these filter also. So, when you hover on this one, it is showing. See, it is asking you to give the function kind of thing. So I'm giving the lambda one. A simple function. For all the one who don't know, I'm repeating this. What is the significance means? See, lambda of x for colon x plus 1 I have given. So what it will do means for each element of num2. See, here we have taken num2. Whatever the values here we are getting, for each of them, what it will do, it will take each of them and add +1 to it, and it will give us result. Let's see before writing this one, what is the result, and after this, what is the result. I hope everyone are following. Let me comment this for now and let's see the answer. 1, 2, 3, 4 is my answer. Now, if I use the reduce function, how it is using, we shall see. See, takes one positional argument, but two were given. So what it is expecting us to do is it can be like x comma y, and we need to give like x comma. Let's give us some basic one, sum of this. Okay, 10. So the result is 10. How it is? It is a sum of 1 to 4. It has given. Now, why it didn't work initially means it is taking only x, but I mean, it is expecting two values so that it could reduce with respect to 2. Here, if I hover, it can be seen like callable t comma t comma t. I mean, one in an array and other is showing differently. So it is expecting two parameters there to reduce that one. Okay, it is not with respect to lambda function. Lambda function can be of anything, but the function in which we are using that lambda is is giving the significance to that lambda function. I hope it is understandable now. Now, I hope everyone are taking notes along with me. Now I'm going to do fold function on this one. See, this is also the same thing, but see, if I hover on this one, it is showing the zero value hyphen, the tiddle function, tiddle t. What it is saying is actually we need to fold one value and we need to give to that one. So here 1 comma, let me fold the first, I'm folding one time. So what I will be getting here is 1 comma lambda comma y. I'm giving the same one, x plus y. See, here I haven't given any collect function, but still I got the answer because this is a action. But for all the transformations, it will not be giving the answer like this. Okay, fold, if I say fold like this, what it has done, let's see. 19. See, why it is 19 here? Because if we see for num2 dot fold, if I do, it is 19. Why it is taking 19 means I'm taking only one value here, but in num2, have we partitioned this one? No, right? We didn't partition this using num slice. It is as is. Means how many partitions are there here? 8 total. Correct. 8. And all those 8 again will be in one particular. See, all these partitions are here like this. And again, for all of them, one array is again there. So total, how many will be there? 9, right? So 9 plus the answer of this will be 10. 10 plus how many partitions? 9. So the answer is 19. Let me not use that one. Let me use the simple one for our convenience. Okay. for our understanding. Give me a moment. Sorry. So num3 is equal to 0. Now let's see the answer for this one. Now the answer is 21. Count of all these, it is 12, and 12 plus 9. 9 because I haven't given anything. Let me give one partition. Then what will be the answer, Vishwas? Now the answer is 14. The original answer for this lambda function is 12. Correct. And again, how many partitions do we have? If I give one, what it will do? It will take the complete one as one, and the whole of that is one. So two are there. If I give one, it is dividing it into two. So that's why our answer is 14. Please let me know if it is not understandable. I will repeat it again. See, this is what I want to show you. How many partitions are there? This whole partition is one partition, and the outer one is considered as one, means two partitions are there. If I consider one, I'm getting an answer of 14. If I consider as two, let us check the, see here, how many are there now? Three, right? This is 1, 2, and the whole is 3. Now you can see the answer. Now it will change to 15. Why? Another one has been added. If I change it to 2, what will be the answer? Let's see. It is changing it into 18. Why? Because 3 times of 2 is 6. Correct? Means how many partitions are there? Are 3 into 2 is 6 plus this answer is 18. This will work with any function. You do see, since it is a sum operation, here we are getting as 18. Let's say if it is a multiplication, what will be the answer? See, 320. If it is 1, it will multiply. That is what I want to let you know exactly. Means whatever the function here we are taking is what it is actually doing. If we take the multiplication, it is multiplying. If we take the addition, it is adding. So it is how it is working. Okay. So now let's move to the next one. Take the assignment of this one. You can do this for multiplication on your own and see the results. Okay. This is the assignment for today, and now I'm going to the next one. Till now we have checked about the actions which we have seen, and we also seen gloom. Gloom is a transformation. That's why we are writing collect function every time we use gloom, because it will not result any answer until we write it here. Okay. So transformations are again divided into two, that is narrow and wide. What is the significance of that means? if the data is getting shuffled between the nodes, then it is a wide transformation. If the data is not required to shuffle in between the nodes, then it is a narrow transformation. For our reference, I have kept the screenshot also. So for any narrow transformation, see, we have divided our job into stages, right? In whatever the stages there, it will execute it and it will give the output as same as is. Okay, but in wide transformations, what it is doing, it is shuffling the data between the nodes. Okay, so this is the difference between narrow and wide transformations. We will be looking into few of the operations here, and I'll be giving you assignments for this one. Okay. So for this narrow, we need to see, we will be seeing the map one first. I hope everyone are following up with me. If you feel anything needs to be repeated, please let me know. Or if you feel you need some time to take the things what I'm saying and execute in your notebook, if you need some time, please raise your hand and tell me so that I will pause. I will hold. Okay. If you don't say anything, I will go on. And by the end of the day, you didn't listen this one and you didn't do your work also. It should not be the case. Neither doing this nor that is not a good idea. So be it anything, even if it is a single thing or it is a very small thing, please let me know. Okay. Now we have entered into the transformation operations. So in this one, we are going to work on map one first. So let me create names. You can also create your own thing along with me. Create one RDD of your choice. Now that we are using the map function, so this lambda function is highly used in reduce, map, fold, and few others in our coming classes. So let me use this here. So map of what I'm going to map is for every X, add Mr. Okay. See, I haven't tried any collect function. So what it has executed, it is saying that it has been executed, but we are not getting any output because this is a transformation function. We shall add collect here so that we'll be knowing the answer, what it is. So each and every element which I have taken here, it has been added. So it is just mapping the thing which I am giving here. So this is map. There is a difference between map and flat map. We shall see that one. I'm still using the same one now, the same names dot flat map of. Let me write the same thing here. Let's see what it will do. Okay. Just to understand the difference between map and flat map. So what it has taken here is a different thing. R dot space JACK. So see, for here everything has been declared in one RDD, but here for the same lambda function, what happened? It is utilizing the same thing, but in a different manner. What it is doing, it will result the same thing here also, but it is creating more partitions. Means using the same operation, it will for each and every element of this one, it will keep the same element and it will use the same element, creating into multiple partitions. Wait, let me give you one more example for this one. X comma 67. Okay, let's see what it will be. See, for each and every element of X, it is adding it is just taking 67 along with them. If I use the same thing here, it will be the different case again. You need to understand the difference between map and flat map. Okay. See, here it is taking all as tuple. For each and every element, it is creating a tuple like this. But here, instead, what it is saying, what it is doing, it is considered everything into one RDD. Means it is flattening the results into one complete RDD. It is not creating any tuples. This is the major difference between flat and flat map. Execute this from your end. I will be going to ask you question at the end of this session today, and I'll be assigning you some assignments. Okay. So please concentrate on what I'm saying, because these whatever the functions we are having, map, flat map, whatever we use, we will be using them for in further session also, but in a different way, in a different operations again. So that's why I'm saying you again and again. Now I'm going to use filter one now. Dot filter off for the same one. Let me create a function like filter. Filter itself, it is saying we need to filter the values upon that one. So let me take any of this one. Num3 I'll take, okay? Which was already created above. Once you have created anything, it can be used throughout the notebook. I mean, within this notebook, you can use it anywhere. Once you initialize it, it can be used anytime. So we need to give the correct function as well here. So num3 I'm using here. The num3 is having these values 2415. So greater than 2 are only two values, 4 and 5, which were written here. See, all the things which we are discussing now are very basic, and these all are you must have used in Python, or some you must have used in Python, some you must have used in SQL in your regular classes. But the same thing when you are using it in the PySpark with a different syntax, nothing more than that one. So in this session, what we are saying is all the things which you already know, but the thing is the syntax is how it differs from here to other languages which you already know. Okay. So now how many we have completed here? So in the narrow transformations, we have checked map, flat map, and filter. Correct. So take the assignment of map partition here and sample also. And I will show you how the union will be in this narrow transformation. Okay. Can anyone tell me what is the significance of union in SQL? Come on, please.
Combining both tables.
Yes, correct. Your good name, please.
Jashwant Verma, ma'am.
Yashodhar.
Jashwant Verma.
Jashwant. Okay, okay. Jashwant. Yeah, thank you, Jashwant. Combining of two tables. So the significance of union in SQL is combining of two tables. He is right. So now we are using the same function here also. We will be using the union here. But for RDDs, how it will work, we will just see. Okay. We already have num3. We already have num3, and previously we have already created num2, right? Which is the range of 1 to 5. Now let's union both of them, and let's see what it will be. So initially, this is the num2 range of 1 to 5 we have given. Na? So 1, 2, 3, 4. There it is. And the num3 values is 2, 4, 1, 5. So one after the other, it is just combining both the things. This is what it is for union. Okay. So upon using these functions, you need to understand, like, see, for all the narrow functions like map, filter, union, till now we have seen this one. So is there any chance of uh, agree? I mean, like, for all of them, what we are doing, mapping things for each element. So within the nodes, it could do it. There is no need of any shuffling, be it filter or again for filter, it needs to filter greater than 2 for each and every upon this diagram. I'll tell you. See, for every stage, it will take now. Here, 1 to 5, 1 to 4 numbers it has taken. 1, 2, 3, 4 can be here. So in each and every stage, it will look for greater than 2 is there or not, greater than 2 is there or not, greater than 2 is there or not. So it will check and it will give the output. That's all. Is there any need for shuffling this one? No, right? So this is what it is signifying here. Beat map. See, union also. For union also, you are just aggregating it, combining it. This one and this one. That's all. But there is no need of any shuffling the things. When it comes to the wider transformations, if you see here, intersection, distinct, reduce by key, group by key, join, partition, repartition, and this one. So if I say using this diagram, what it will do for intersection? Can anyone tell me what is the intersection mean in SQL? or you might have seen Venn diagrams also in your schooling. So you can tell me anything, whatever you
data.
know about intersection. Sorry?
Common data.
Correct. Common data of
Common
two
data
tables.
between the two tables.
Correct,
Between two
correct.
tables.
Yeah, thank you everyone. So what it is, intersection means it is a common data between those two tables. Means, see, in this stage, it might have given 1, 2, 3, and 4, 5, 1, 2 are there, and 3, 4 are there here. And in the second one, let's say the whole num2 here. I have taken, this is num2 and this is num3. 1, 2 are in one stage, 3, 4 are in one stage, and this whole 2, 4, 1, 5 is in one stage. Let's consider like that, okay? In this stage. So to do the intersection, do you feel there is a need of shuffling the things or not? Yes, right. We need to shuffle this because until you don't have the aggregate data with you, complete data with you, you cannot do anything. Correct. Firstly, you will be joining all of them, and then you will be again doing the intersection upon the result. But here, what we have taken, whatever we have taken for each stage, the results are different. But here, for each stage, could you process that one? No, right? You need to shuffle the data. You need to aggregate the for intersection and do that. So that is how the wider transformations will usually takes place. I hope this is understandable for everyone. If not, let me know. I will repeat this once again. At least a reaction that you understood this one. I need at least a reaction from all of you. What, guys? Yeah, if someone is having doubt, yes, you can go ahead. Someone raised your hand. Okay, okay. Fine, thank you. If you don't answer anything, what should I feel? Whether you all are sleeping now or what? What should I feel? You tell me. I'm only speaking it throughout the class and no one are speaking. And at least sharing the reactions to share the reactions also. Many of you are not responding for reactions also. Is this a very sleepy class? Is this a sleepy class? You're sharing your reaction? No. Okay. Okay. Then I will change the method of explaining you from tomorrow. Okay. See, from today onwards, you will be having the continuous lab sessions only. Like every day, we will be working. Today, we will be working on these transformations and data frames. We will be creating the data frames and all. So from now onwards, it will be a complete lab session only. So please try to be more concentrated because now you are working on this RDDs. Tomorrow you might be working on the data frames. See, but there also you'll be using the same operations and all. You will be doing the things samely, but there will be some minor differences. You need to correlate that one. So try to be concentrated in each class. And if you don't understand something or if you have any concerns, please raise your hand and unmute yourself. Okay. Now I'm going to the next one. Please take the assignment. Please write it. Okay. What I have given: map partition sample from narrow transformations, and in wide transformations intersection we already discussed. Correct. Distant we already know. Take this one: Cartesian, partition, and coalesce. This all these three you need to uh, take it and you need to execute it from your end and get back with your answers tomorrow. Okay. From actions, you can check the for each one. today we have seen the major one is the lambda function. In for each also use the lambda function and try to iterate it throughout the throughout the array. Okay, in for each also. Num2 dot intersection dot num3 of dot color. So this is the intersection one. So what are the common elements we have? We got the same thing. So now I will skip the distinct one. See, this is the another important operations which you need to understand. One is reduce by and other is group by. Okay. So reduce by, you already know this reduce here, and group by also you already know, right? Group functions we already know. So can anyone tell me what is how we use the group by in SQL? What is its significance? Because it will be the same thing in here also. Please unmute yourself and let me know the answer or raise your hands.
To group things, use something fine.
It. Can I know your name, please?
Karthikeyan.
Sorry.
My name is Karthikeyan.
Sorry, I couldn't hear you.
He is the same guy yesterday helped you, Kartikeya.
Karthikeya, oh, Karthikeya, thank you, thank you. Okay, Karthikeya, yes, you are right. Group by is to grouping the things. In SQL, usually if we have the data for names and their cities, if we have, let's say, this is an example, name and their cities, then when we want how many, how many cities are there, and in each city how many people are residing, for that particular things what we use usually group by, right? Group by city, we will be getting the count of the people who are residing in that particular city. So it is just grouping the things inside. So here also it is the same thing, nothing more than that one. Now we will start with reduce by. It is also the same function, but understand the difference between reduce by and group by. Okay. First, we should start with reduce by. I'm giving you time because you will also do these things along with me. Okay. So now we shall take the new one. This time integers. Let's take like that. See what parallelize of some integers. 45, some random numbers you can take. Okay, no need of any specifications for the data. And now we are going to do the reduce by on integers. See, when I write something like this, you need to question, like, see, all are in integer format only. How we will be doing how we will be reducing this one, reducing this with a lambda function. We are going to use lambda functions again. Let me take x plus 1 again. It is saying reduced by is not different. So, means it is saying we cannot reduce directly without having anything. So let's take the things in key value pairs. Okay. Let me give 1 comma Mike. In a key value pairs, let's take, and so that what we can do, we can reduce by keys and values. Okay. So this time the lambda function will be deferred, reduced by we have two parameters, right? So let's take x comma y. For every x comma y, what we can do is we shall write like x dot y, something like that we shall do. Okay. Let me collect it to see the answer. Okay, let me use any function which is understandable for that one. Plus 1. Or x greater than 1, we shall take. Let me take the key value pairs in this way and see. Just because both are not strings, it might not be working. But sorry, both are different things, it might not be working. Now let's see for this one. Okay. So see, for reduced by key, what it has done is for every key value pair x comma y, x greater than 1, okay, it has taken by key. We have taken this by key, but what it has done exactly means this 2 comma 5 and this 2 comma 4 are two different things. So what it has done, it has merged both of them and taken it into one, reduced by key. So it reduced to one single section. And I have given just like if it is greater than 1 or not. But see here, this particular one is greater than 1. No, but this is greater than 1. And this is also greater than 1. But only for this particular, what we say, only for this particular element, which is 2, which is common, is resulting a different thing, which is true value. Now let's change the function and see what it will result for us. Okay, x plus y we shall do, and we shall understand. See, what it has done. It has merged both of them, and it has done the sum to the values. Means whatever we are giving here, the function, it is being applicable only to the values, but it is merging the values, but it is grouping with respect to keys. So that is the important thing which we need to understand here. Likewise, if you do multiplication or subtraction, whatever it is, it will be the same thing. Now we shall go to the group by function and execute the same thing. What it will do, we shall see. Okay. Integers dot. Missing one positional augment to y. Okay. Okay, somehow it is not understanding what we are saying because of the braces issue. Why it couldn't take this one? I'm not sure. Wait, group by. Okay, we have given only group by. We haven't given anything. That's why it is not showing anything. Wait. Function has not really get object ID. Okay, let's do one thing. Let me remove the whole thing and see what will be the answer without using any lambda function. Okay, now let me print the result of this. So it is not giving me the expected results. Let us see. Let us do one thing. So instead of printing it here, what we shall do is, let me write a function for every key and value in result. In the key and also the list of values. See, my expectation, why I'm not getting expected result means when I'm doing this one, I need to get like something like this, or it should be like 1, 2, and 2 for 2, it should come as 4, 5, something like that it should come, but it is not coming anything, right? So we shall be iterating this one and check this one. So the issue, what happened here is even though we have given the color function, even though we have given everything, why it didn't work means uh, the the result of this one is again a iterable one, means again a array, right? So here we have taken the as a list, but here it is having two values for one element. So it couldn't understand how to display that particular thing. So whenever we are using it, we need to identify the significance of the particular thing and we need to execute accordingly. So every time we use the group by, it will be grouping the things which are similar. So reduce also do the same thing and this also do the same thing. But see here, the outputs are different. Here it has given the tuples and in each tuple it has given the answers like for one it is 2, it is reduced by key, so it has merged these two and whatever the function I have given it has taken, but group by key I have taken. It has grouped the things, but if it is more than one it couldn't provide the result in tuple format. That's why it is expecting us to write it in a list format. So uh, when we use this one, it has given the result. So the difference between these two will be like, I'll show you in paint one. So how it will do, or in this diagram only we can see it. See, this one is the stage one. This one will be the stage two, stage three, something like that one. So what the reduce by will do means for every stage, it will calculate the results. And again, it will shuffle the results and it will do the things. But in group by, it will directly shuffle the things, but it will not take the intermediate results. So this is how it actually works. That is the difference between the group by and reduce by. Now we can do one thing. Instead of this one, let me write one more thing, okay? I can write like this also, integers dot group by key and dot map by values. I can use this, right? In the result. How I can map? I will map by some. I'm taking the default something like that. Okay. Result dot select off. There's no attribute map by values. So here it is saying it is not having any attribute map by values. But
I think it's only map values.
correct. It is only map values, right? So that is the issue here. Now see, this time we got the sum. If I take the max function here, let's see the result, okay? what it has done now, if I throw max here, it has taken, it has compared the two values of two and it has taken the maps out of that. So this is how it worked for this one, for map values. Okay. So now what you can conclude upon these results, this is the reduce by, this is the result of group by plus map values. So what you can conclude upon seeing the results, I will keep the sum as here, okay, for our reference, okay. Okay, now conclude something upon seeing the results of these two. Both are having the same results, correct? Means what you can draw the conclusion out of this is the group reduced by is equal to group by key plus map by values, correct? Able to follow up with me, everyone? Okay. So is this clear? This group by function and reduce by function, or should I repeat this once again? Please let me know if you have any questions. Okay, I'll take this silence as yes. So please try to be focused and do along with me. Yes, if someone is having doubt, please continue. Okay. So tomorrow, if I ask you question regarding the narrow and wide, you will be able to answer, right? Say yes or no. Yeah, at least one reaction. Thank you. So see here, I have given you assignment for today. You have noted it down, right? Or shall I post it in chat once again? Take the sample one. Flat map I have told you. So map partition you can take. Map partition, sample in narrow transformations, and in wide you need to do Cartesian, repartition, and this one. So I will explain you join. Join you already know. Can anyone tell me what is the join in SQL?
Combining two tables.
Combining tables.
Correct. See, union is also combining the two tables and joining is also combining the two tables. What is the difference between join and the union?
Based on a common
Join condition. Join
Yes,
based
please.
on condition.
Okay. Correct.
Union.
And
There
union?
is no condition. Combining all the data.
Correct. Your good name, please?
Jashwant Verma, ma'am.
Jashwant, yeah. Good. That's correct. And the other one who answered, I want his name also. He also answered it well. Can I know the other name? Okay, that's fine. So yeah, union is just combining both the things, but joining is based on the conditions. So in SQL, how many joins we have? Can anyone answer me this question?
4 joins.
4, ma'am.
four.
Huh, you can tell me them.
Inner join, left outer join, right outer join.
Correct. So in this also, in our PySpark also, we'll be having the same things. So take this also as an assignment. You do execute this for all the joins, left, right, and inner. Okay. If you do full also, what will be the result? You can see it. So understand each and everything. See, for few of the functions, we have used single array, and it could suffice our what it could suffice whatever the function we are doing. It could do it. But in most of the things, what we have done today is we have used lambda function. Why we have used lambda function? Many of functions we have used in reduce, reduce by, group by, we have used in, and in filter also, no, in filter we didn't used. In intersection we have used key value pairs. Wherever we require key value pairs, something like that, we have used that one. So before you do take any sample to operate on that one, try to understand. You can execute it with a single array. If it is not working out, then try it with the key value pairs. Then try to implement the lambda function. Okay, these all three things we have done today. We have used a single array as a sample. We have used lambda function to iterate that one in reduce and fold kind of functions. Okay, and we have used key value pairs just to check the data, like group by, reduce by. We have used particularly this group by will be operate only on key value pairs. So this is how it will be. So try all the three and understand, okay, for this function we need to utilize this one, something like that you need to understand. Okay, tomorrow you will be coming with all these answers, right? See, in actions, take the assignment of aggregate for each. I will type it here for all your reference. Join, and intersection also you take it, and intersection, and practice all the things which we have discussed today and start your practice. Okay, sample map partition. Regional aggregate, right? For each aggregate partition. This is the assignment for all of you tomorrow. Okay, let me know if you have any doubts on this tomorrow when we start the session. Okay, in today's session we have learned about the complete transformations and actions, and we have executed most of the actions and most of the transformations, and understanding the differences between the reduce, fold, and here we have taken reduce by and group by, and here we have seen the difference between map and flat map. See, while you're learning, understand the differences and learn from differences. It will be the key for you to remember the things, memorize the things. You just go and do it. It will not be memorized to you, but understand from differences. If there is anything, okay, then it will be more productive for you. I hope you all have taken the questions, so, assignment for today. Sir, you can stop the recording today.
Okay, madam.
Okay, guys, do you have any questions, or we can close this session and I will give you 6 minutes back to you all today?